Now we're gonna start with exercise 11.1. So we will be doing question number 1. So first thing, let's read the question first. It says if a line makes angles 90 degree, 135 degree, 45 degree with x-axis, y-axis and z-axis respectively, find its direction cosines. Let's do it. So the direction cosines are what? The direction cosines are cos alpha, cos beta and cos gamma. So cos alpha is equal to what? Cos 90 degree, and that is equal to 0. Cos 135 degree will be equal to what? That is equal to what? Cos 180 degree minus 45 degree. Now 180 degree means what? It's an even multiple of 90 degree. So cos will remain cos. Which quadrant does it lie? 135 degree lies in second quadrant, and in second quadrant cos is negative. So this one will be cos 45 degree. So it is minus 1 by root 2. Now the last one, cos 45 degree, and that is equal to 1 by root 2. So the direction cosines are 0, minus 1 by root 2 and 1 by root 2. Now question number 2. Let's see what it says. It says find the direction cosines of a line which makes equal angles with the coordinate axis. Now if it makes equal angles with the coordinate axis, what we can say? Since the line makes equal angles with the coordinate axis, since the line makes equal angle with the coordinate axis, then cos alpha is equal to cos beta is equal to cos gamma, right? Now we have a relation. What relation we have? Cos square alpha. So we write now cos square alpha plus cos square beta plus cos square gamma is equal to, we already derived this one, that is equal to 1, right? So now these three are equal. So I can write 3 cos square alpha is equal to 1. Therefore cos square alpha is equal to 1 by 3. So therefore cos alpha is equal to plus minus 1 by root 3, right? So the direction cosines will be what? Therefore direction cosines are it will be what? 1 by root 3 plus minus 1 by root 3 plus minus 1 by root 3. Okay. Now let's move on to question number 3. In question number 3 it says if a line has the direction ratios minus 18, 12, minus 4, then what are its direction cosines? So in vectors we have already learned, if I have a vector, a vector is equal to xi cap plus yj cap plus zk cap, then the direction ratios are what? X, y, z, right? Now if I have 2 points, this one just we have learned, if I have 2 points PQ, the direction ratios of this PQ is equal to what? Suppose the coordinate of P is x1, y1, z1, x2, y2, z2. If they ask you what are the direction cosines of PQ, so what you will say? x2 minus x1, y2 minus y1 and z2 minus z1, right? And what was the formula of the direction cosines? Cos alpha was equal to what? X by r, right? And r is equal to what? Root over of x square plus y square plus z square. So here the direction cosines the direction ratios are minus 18, 12 and minus 4, right? So we are asked to find the direction cosines. So first thing first, let us find cos alpha. What is cos alpha equal to? It is minus 18 divided by root over of minus 18 whole square plus 12 square plus minus 4 square. Yes or no? So how much will it be? So let us take 2 square out from every single one of them. So minus 18, if I take 2 square from here, so it will be 2 root over of, it will be 9 square. If I take 2 square from here, 6 square, and this one will be 2 square. So how much is that? This one cut, it is 9. So minus 9 divided by, how much is it? 81, 81 plus 36 plus 4, 40. It's 121, and that's 11. So it is minus 9 by 11. In the same way, cos beta will be equal to how much? It will be 12 divided by, we have already got 22, right? The whole thing was 22 because we have taken 2 out, and this one is what? 11. So 22. So how much is that? 2, 6, 2, 11. So it is what? 6 by 11. And cos gamma, the last one, that is equal to minus 4 divided by 22. That is your minus 2 by 11. Okay? Now today we are going to start this video with question number 4 of exercise 11.31. So exercise 11.1, question number 4. First read the question, what it says. It says, show that the points 2, 3, 4, minus 1, minus 2, 1, 5, 8, 7 are collinear. So first thing, let's give the points a name. So let A 2, 3, 4 B minus 1, minus 2, 1, minus 1, minus 2, 1, and C 5, 8, 7 be the points. So these 3 points we have A, B, C. Suppose like this. We have to prove that they are collinear. Now how can I prove that they are collinear? First thing what I will do, I will find the direction ratio of AB. Okay. Then I will find the direction ratio of BC. Now if the direction of ratio of AB is proportional to direction ratio of BC, then we can say what? That AB is parallel to BC. Now one thing, we cannot have like this, AB is parallel to BC. Why we cannot have? Because the point B is common to both this line, right? So this is the only way how we can have ABC, as AB and BC to be parallel. Clear? They have to line in a single line. So that's why they have to be collinear. So let's start with it. So the direction ratios of AB, what is that? 2 minus 1. So I will just write like this. So it will be AB I'm finding. So terminal minus initial. So it will be minus 1 minus 2. Then it will be minus 2 minus 3. Then it will be 1 minus 4. 1 minus 4. Okay. So how much is that? So it is minus 3 minus 5 minus 3. So this is how we get the direction ratios of the line AB, right? In the same way, find out the direction ratios of the line BC. The direction ratios of BC is equal to, what are that? So the terminal minus initial, so 5 minus 5 minus of minus 1 becomes 5 plus 1. Then 8 minus of minus 2, that is 8 plus 2. Then 7 minus 1. So what is that? So it is 6, this is 10, and this is 6. So what I see is this AB and BC, they are proportional, right? How? Look, 6 by minus 3 is what? Minus 2. 10 by minus 5 is what? Minus 2. And 6 by minus 3, again minus 2. So we can say what? That the line AB and BC are proportional. The line AB and BC are parallel. The line AB and BC are parallel since their direction ratios are proportional. Right? Now, so I will write since the point B is common to both the lines, hence the points A, B and C are what? Collinear. That's it. Understood? Now we move into question number 5. So what it says is, we have to find the direction cosines of the sides of a triangle whose vertices are 3, 5, minus 4, minus 1, 1, 2 and minus 5, minus 2. So let's do it. So first let's give the points its name. Let A 3, 5, minus 4, B minus 1, 1, 2 and C minus 5, minus 2 be the 3 vertices of the triangle. Clear? So what we have a triangle that is A, B, C, and we have to find the direction cosines of those sides of the triangle. Okay, so we have to find the direction cosines of AB, BC and AC. So let's start with AB. Now first thing, tell me, what was the direction cosine? Let's write this one. Direction cosine of a line joining 2 points What was that? R. What was that? Direction cosines of a line joining 2 points are, it is what? x2 minus x1 divided by root over of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is cos alpha. Now we have y2 minus y1 divided by root over of the same thing, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Right? Now the other one, what was that? The other one was, sorry, I don't have space in here. Let's write in here, z2 minus z1 divided by root over of z2, sorry, this ones will be same, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is basically, the below one is basically the magnitude of the line, the length of the line. So now, so we have to find the direction cosine of AB. So what will be that? So therefore direction cosines of AB is equal to, what was that? X2 minus X1. So AB, these are X2, Y2, Z2, this point, and X1, Y1, Z1 is this point. So this minus this, minus 1 minus 3, divided by root over of, so how much is that? Minus 3 whole square plus 1 minus 5 whole square plus 2 minus of minus 4, that is 2 plus 4 whole square. This is our first part we got. Then the next part, acha, let's directly solve this one. What do you get? Minus 4 divided by, this is coming root over of 16 plus 1 minus 5, that is 4, 4 square is 16 plus 4 plus 2 is 6, 6 square is 36. The reason I want to solve this one, because I don't want to write this one again and again. So what do I get? So this one is your minus 4 divided by root over of, how much is that? 68. And 68, if you do the LCM, so what I get is 2, 34 and 2, 17. So we can take out 2 from here. So we get minus 4 divided by 2 root 17. So this one is your 2. So this is equal to minus 2 by root 17. Am I clear? So let's do the rest. So it will be what? Y2 minus Y1. So where is your Y2? Y2 will be what? This one. Y2 minus Y1. So 1 minus 5 divided by root over of, how much is that? 68. Now the Z2 minus Z1. What will be Z2 minus Z1? Z2 minus Z1 will be 2 minus of minus 4, that is 2 plus 4 divided by root 68. Yes or no? So how much we are getting? This is what? Minus 4 divided by 2 root 17. And this one is what? 6 divided by 2 root 17. So this one cuts. This one 2. So I get minus 2 by root 17. I get 3 by root 17. I think we have to write it again. Last time we have to write. So the answer of, so this is our answer. Minus 2 by root 17, minus 2 by root 17 and 3 by root 17. Am I clear? Okay, so this is direction cosine of one particular line, that is AB. So BC and CD is BC and AC, you find it yourself. Okay, clear?